Alright, welcome to today's lesson on programming structures. This is the second part in our series about the repetition structure. And if you remember, we had multiple different types of programming structures that exist. The first type we had was called sequence, and this was the usual flow of program where lines of code were executed one after the other in the sequence they appear, much like reading a book. The second type was selection. That's what we were working on over the last week. This is where we made a decision whether or not to do one section of code or another section of code based on the comparison of two or more values. And today we're going to be talking about the third type of programming structure called repetition, where we can repeat a block of code over and over again a bunch of times. So, repetition structures. A repetition structure is a point in the program where a block of code is repeated a number of times. It can be more than once. It could actually even be 0 times depending on the situation. To do this, we have to set an ending condition. We have to tell the program when we want to stop looping the code or repeating the code over and over again. And the program is going to keep executing sections of code over and over and over until that ending condition is met. And there are two ways that we can do this. The first way is called a for loop. This is an example of a counting loop, and it repeats the code a specific number of times. The second type is called a while loop or a conditional loop. And this is where we repeat the code until a specific condition is met. And this way we could go on indefinitely if the condition is never in fact met. So we'll talk about the for loop first. The loop structure for a for loop has three sections. The first is the keyword for. The second section is the control statements telling us how many times we're going to be looping. And then the third section is the code that we're actually going to be repeating over and over again that we call the body of the repetition. Okay? There are three sections to the control statements in the center here. The first is called the index declaration and initialization. The index is essentially going to be a variable that's going to be used to count the number of times we've gone through our loop. We also have the test condition, which tests to see if we've run our loop a certain number of times. And we have the incrementation, which is going to allow us to increase or decrease the value of our index each time we pass through the loop. Okay, so here's that stuff that I just finished saying, again in detail. So the index initialization prepares the loop counter for execution. So I've got a variable, which is going to be my counter, and it's going to count the number of times I've done my loop. I have a test condition. Each time I pass through the loop, after I've run the code, it's going to check this test condition. If this test condition evaluates to true, the loop is going to run again, and it keeps on going until it's no longer true. And then we have the incrementation portion, which updates the loop index. It's going to increase or decrease the value of this counter. Let's take a look at what this looks like in code. So here I have some code. Again, you can see the keyword for, and inside the smooth brackets I have my three different parts. My index initialization, my test condition, and my incrementation value. And then in between the squiggly brackets, I have the body of code that's going to be repeated over and over again. So what I want you to do now is I want you to set up a table, and I want you to figure out what this code would do. So you can pause the video here, figure out the code. Alright, so if I were to try and figure out this code, I'd have my table set up, and I'd have my counter, which I've called I. That's my variable that's going to be my index. I've called it I here. And then I've got my output. So we start off with I being equal to 0. And it goes as long as I is less than or equal to 10. So if is 0 less than 10? Yes, it is. That means I'm going to go through my loop. So I'm going to print I is equal to 0, because that's what I is. Then I'm going to go through and I'm going to change my index based on the incrementation value. So in this case, I'm going to add 1 to it. So I is now 1. I check it again. Is 1 less than or equal to 10? Yes, it is. So I'm going to run my body of code. So now I is equal to 1. I come back up, increase my index again. It's now going to be a 2. I run my code. I is equal to 2. And I'm going to continue doing this 3, 4, 5, all the way up until I get to I is equal to 10. When I get to I is equal to 10, 10 is still less than or equal to 10, so I'm going to output I is equal to, is equal to 10. Then I'm going to increase my counter. It's going to be 11. And because 11 is no longer less than or equal to 10, I exit my code, and I'm going to continue on with my program, whatever is outside of this squiggly bracket. Okay, so you get something that looks like this. I equals 0, 1, 2, 3, all the way up to I equal 10, and then we finish. Here's a second example, which is a little bit different. Again, pause the video and try and see if you can figure out what the output is going to be. So if I was going to do it, I would set up my table. We've got my variable this time is called num. That's my index, num. And I've got my output. It's going to be printed each time my loop executes. This time, instead of starting at 0, my value is going to start at 4. Is 4 less than 10? Yes, it is. So I'm going to output num is a little bit messy here, 4. Now in this case, my incrementation value is not going up by 1, it's going up by 2s. So now 4 plus 2 is going to be 6. So num is now 6. 6 is still less than 10, so num is 6 gets outputted. So I can move up again, increment my value. 6 plus 2 is going to be 8. 8 is still less than 10, so I run again. Num is 8. I increment again by 2. Num is now going to be a 10. And since 10 is not less than 10, I exit my loop and I continue on with my code. So in this case, I'm only going to get 3 lines of output. Num is 4, num is 6, and num is 8. So that's the for loop. The second type of loop was called the conditional loop, or the while loop. Okay? In the while loop, we create a loop that consists of only one condition. So instead of counting and adding up the number of times I've done it, I just have a condition. And as long as that condition evaluates to true, I'm going to continue on running the block of code. So it looks like this. Very similar to the for loop. Instead of using for as our keyword, we're now using the while as a keyword. The rest of it is the same. Let's take a look at an example. So again, pause the video, see if you can figure out what this code is going to output. So in this case, I have a variable called x. And x has been made to be equal to 0. I've still got output that happens, and you'll notice in this case I actually have 2 statements that are being run as part of my loop, and I can run an unlimited number of statements in here. So in this case I'm going to go right ahead. X is less than 10, yes it is. So x is going to equal to 0. And now here, x plus plus, remember that code from previously? That means you're going to add 1 to the value of x. So x is now a 1. 1 is less than 10, so I'm going to enter my loop. X is equal to 1. X plus plus. So what I've sort of done here in this case is I've set up my own version of a counter. So x is going to be a counter, and I'm going to keep adding 1 to it. So ultimately, this code here is going to keep running just like my for loop before did, all the way through until I get down to 9. So x would print out x is equal to 9. And then I'm going to add 1 to x, so it becomes a 10. 10 is no longer less than or equal to 10. So therefore, I stop. And my output only goes up to x equals 9. That's the while loop. A third type of loop is also a subset of the while loop. It's called a do while loop. And this is used when it's more convenient to test my condition at the end of the loop instead of at the beginning. So in this case, I'm going to ensure that I run through the code once for sure, then I'll test it to see if I want to repeat it a second time or not. Okay? This is accomplished by modifying the while statement to include a do, so it looks like this. So I've got a variable called continue, it's a string variable, and at some point in time the user's going to have an option to set it equal to either true or false. So here's my code, everything that's going to happen within my loop and be repeated. First I'm going to do something. This is a method that doesn't really exist. It's a fake method that quote unquote does something. So for example, it plays my game. Okay? Once we've done whatever this method does, we're going to print do you want to play again and ask the user to input it. And as long as my variable called continue is equal to y, then I'm going to continue. If it equals y for yes, then I go back up and I run this whole loop again. And I'm going to continue doing that as long as they say play again, play again, play again. I'm going to keep on doing it. So in theory, I could do this indefinitely. I could do it forever until they put in anything other than a y. It doesn't even have to be an n. Anything other than a y would break out of this loop and it would be finished. So that's it. That's a brief introduction into repetition structures, both the for loop and the while loop. We'll see you in class tomorrow when we'll practice what we've learned.